This is Algebra 2, Section 4-4, Factoring Quadratic Expressions. Our objective today is to find the common and binomial factors of quadratic expressions. Tomorrow we'll cover the second part, which is to factor special quadratic expressions. So we start off with our bell work. In a game, you see the two cards shown. You get the other two cards with numbers. You win if the product of your two numbers equals the number on one card shown, and the sum of your two numbers equals the number on the other card shown. What should your two cards be for you to win the game? And is there more than one answer? Explain. So we need to draw two cards that when we add them together, it equals one, but when we multiply them together, it equals the other. Well, I can think of 2 plus 3. 2 plus 3 is equal to 5, but when you multiply them, you get a 6. So there's two cards. So we could draw a card 2 and a card 3. Now, is there any other answer? Yes. How about 5 times 1? So now we can go 5 times 1, and then when we add them, 5 plus 1. So when we multiply, we get a 5, and when we add them, we get a 6. So those are the other examples, 5 and 1. And so that was our bell work. And thinking like this, what two numbers can I multiply and get one answer, but when I add them, I get a different? That's exactly what we need for our lesson today. So this was prep for our lesson about factoring. So factoring is just rewriting an expression as a product of its factors. In Algebra 1, we did this. This is just review of Algebra 1 and some pre-algebra with the FOIL process. So we can factor many quadratic trinomials in this form, ax squared plus bx plus c, into a product of two binomials. So x plus a number, we'll call it y, and x plus z, some other number. Okay? So any trinomial in this form, we can most likely factor into two binomials. Today we're going to focus on when a is equal to 1 or negative 1. So it will begin with an x squared or a negative x squared. Okay. We're going to use the FOIL process to check our work when we're done. And I will talk more about this in a minute. If you want to pause the video and read through this, if you're new to it, you may. But I will go through this completely on the first problem. Problem 1 is, what is the expression in factored form of x squared plus 9x plus 20? So when you see this, I'm going to use something called a magic x. And I'm going to look at this third term. I'm going to say, what two factors of 20 can I add up to be a positive 9? So your third term goes in the top, your middle term goes in the bottom. Okay, and so I need to find two numbers here we're going to put on each side that when I multiply, I get a 20, and when I add them, I get a 9. So that would be 5 and 4, right? Because 5 times 4 is 20, and 5 plus 4 is 9. So these become my answer. Now I have to write it as a binomial. So x plus 5, it's a positive 5, times x, and it's a positive 4, plus 4. So that's my answer. Now let's check it. You check it with the FOIL process. FOIL means first, outside, inside, last. Okay, so when you do the first, you're taking the first of each term, each binomial, excuse me, the first term of each binomial. So x times x is your first. So there's your first. Now we're going to add to that the outside terms. Outside is the 4 and the x. Oops. And now the inside terms, right there, 5 times x. And the last the last are your last terms in each binomial. So it's going to be 5 times 4. So first, outside, inside, last. Now let's simplify. X squared plus 4x plus 5x plus 20. Right? And combine your like terms here. 9x. So we have x squared plus 9x plus 20. Does that match our original equation? Yes, it does. So that checks our answer, and that means our answer is correct. So if I can clean this back up, our answer is x plus 5. Almost. There we go. X plus 5 times x plus 4. So that's our answer. And make sure that you box your answers so they stand out in all of this tiny calculations that you have. It gets buried. So make sure your answer stands out. Put a box or a circle around it or highlight it. Okay. Okay, our next problem, our next example, there's a negative sign on the last value, on the C value. So again, we're going to start with our magic X, and how do we factor this? Well, we're going to take that C term, and that goes in the top, negative 72, and the middle term, positive 14, goes on the bottom. Now we say, what two numbers can we multiply and get negative 72? So that means one must be negative and one must be positive. But when we add them, we get a positive 14. Okay, so what two numbers? So you have to write your factors of 72. So we know we've got 1 times 72, 2 times 36. I've got them right here, and I've got a few of them. Now, let's look at the process. So if we know one must be negative, one must be positive, and when we add them, they equal to positive 14, that means your larger numbers have to be the positive, and your smaller numbers have to be the negative. So let's see what happens when I take these factors and add them together. So it would be 72 plus negative 1. That would be a 71. Does that match our 14? No. So that's not it. Let's go to the next one. How about 2 times 36? When multiplied, I get a negative 72, or negative 2 times 36. When I multiply, I get a negative 72. When I add them, I get a positive 34. Well, that doesn't match our 14, but we're getting closer, so that's not it. Now 24 and 3, so actually just let me put all the negative signs there, okay? So multiplied, I get negative 72, but when I add these, I get a 21. It still doesn't match my middle term, 14, so that's not it. Now 18 times negative 4 is negative 72, but when I add them, I get a positive 14. That is our winner. That's the one that matches. So these are our factors. So negative 4 and positive 18. So now we can factor it. X minus 4 times x plus 18. And again, you will FOIL it out, compare it against your original equation up here, and if it checks out, then you're good. Our next equation has a negative sign in our A term. Okay, at the beginning of the lesson I said we'd be working with positive A's and negative A's. When you have a negative A, it's this simple. It's got to be positive, so let's just take it out. So if we pull a negative 1 out of all of this, it flips all the signs. So that becomes a positive, the second term becomes a negative, and the third term flips to a positive. Okay, now we can use our magic X on this, but don't forget that this negative 1 is part of our solution. So now we're going to say what two factors of a positive 12 add up to be negative 13. Oh, well that means both signs have to be negative, right? Because when you multiply a negative times a negative, you get a positive, but when you add a negative and a negative, you get a larger negative. So this is going to be obviously 12 and 1. when I multiply negative 12 times negative 1, I get a positive 12. And when I add negative 12 and negative 1, I get a negative 13. So don't forget the negative 1 we took out at the beginning. And now it's going to be x minus 12 times x minus 1. And it doesn't matter which binomial's first, as long as you have an x minus 12 and an x minus 1 in parentheses, you're good. But the negative 1 does need to go at the beginning. So how do you check these? You're going to FOIL out the two binomials, and after you get that answer, then multiply everything by the negative 1. Then compare it against your original equation, and it should match. But this whole thing right here is your answer. Negative 1 times x minus 12 times x minus 1. Okay. Our next problem set is about finding common factors, and they start us off with some pre-algebra. What is the expression in factored form? And they give us 6n squared plus 9n. Let me go to this page. So what we have to do is say, what do they both share in common? Well, let's do something called prime factorization. So write all your terms out. If it's 2 or 20 terms, you just write them all down here in a list. Okay, and now start factoring. Factor them in all prime numbers. Keep going till they're all prime. So what is 6? It's a 2 times 3, which are both prime. And then n squared is n times n. So 6n squared can be written as 2 times 3 times n times n. And 9n is just 3 times 3, both prime numbers, times n. Okay, and that's all of our terms. They're all in prime, and they're all simplified as far as we can go. So now we look at, what do they share in common? Well, they share a 3, and they share 1n. So that we're going to pull out. And if you had several things, you would just keep pulling them out, multiply them all together into one term, and it goes at the front of your expression here. Okay. Now we look at for what's left over. So for our first term, 6n squared, what do we have left over? A 2n. So that goes in that first spot, that first term. Keep your sign. And for our second term, 9n, we just had a 3 left over. And that's all there is to it. That's your answer. How do you check your work? Well, distribute it back out. So 3n times 2n is 6n squared, and 3n times 3 is 9n. Does that match your original equation? Yes, it does. Then that answer is correct. Okay, see how easy it is for your answers to get lost? Make sure that you're putting a box around everything. Okay, that's how you do these. Now that we're going to combine both things we've learned today into one problem. Now they're going to give us a 4x squared plus 20x minus 56. Okay, well, a is not equal to 1. So it's equal to 4. So you could do all of these and do a prime factorization and take out the common thing. But here's a shortcut. Before you go to that, look at your term that you're trying to get rid of. We need rid of the 4. And say, okay, does 4 go into 20? Yes, it does, 5 times. Does 4 go into itself? Of course, it goes in 1 time. And does 4 go into 56? Yes, it does, 14 times. So we can just factor out a 4 right here without even doing our prime factorization. Okay, so it's going to be x squared plus 5x minus 14. So now, remember, this 4 stays part of our answer. Don't drop it. So many students drop it, and that's a common error. But what we're going to do now is our magic x on the trinomial. So we're going to say, what two factors of negative 14 add up to be a 5? All right, a positive 5. So it's going to be a positive 7 and a negative 2. All right? So when you multiply them, you get a negative 14. And when you add them, you get a positive 5. So it's going to be 4, carry that down, times x plus 7 times x minus 2. So it's just those two numbers. there, and there. Now how do you check this? We'll FOIL out your binomials, FOIL those out, and then multiply everything times 4. If you're good, you can stop the video here and start your assignment. And your assignment is 4-4, the first page, 1 through 22, all. And if you want to see the check, I'll go ahead and do that now. So if you're good to go, stop and begin your assignment. Alright, so I'll go on to check with FOIL, since this one's a little different. So to check this, we want to take our binomial here and FOIL it out. So we're going to have x times x, our first, x squared. And then outside is x times -2, negative 2x. Our inside is 7 times x, so that's plus 7x. And our last terms is x times -2. I'm sorry, daydreaming. 7 times -2, which is -14. Alright, now combine your like terms, and that's going to be a 5x. So we have x squared minus 5x minus 14. I'm sorry, it's a positive 5x because you've got 7x minus 2x. Alright, now we still have that 4 carries down. It's still part of our solution. So the end step is now to distribute the 4 across this trinomial. So 4x squared plus 20x minus 56. Okay, so now we want to look back up at the original equation and see if it matches this. 4x squared plus 20x minus 56. Yes, it does. So then this, I can get all that way. Okay. This is our correct solution. And that's how you do this. Thank you for watching, and see you Monday.